Good morning, everyone. I hope I'm audible. Am I audible, students? You can hear me? Okay. Good morning, Benson. Good morning. Okay, so I got late a little bit. I reached college late actually, that's why. Okay. Okay, so last class, what we did. Today I'm a little bit unwell, okay, so I will go a little bit slow, okay? Okay, let me share my screen. Okay. So last class we have done up to your like skimming tank and detritus tank we have completed, right? So that was your primary treatment. Okay. So that was what your primary treatment, and after your primary treatment, what we have studied there is your preliminary treatment. Okay. So in the preliminary treatment, you can say that sedimentation it is there. Okay. So, like sedimentation, you have already discussed about sedimentation in your this water raw water engineering, right? We have already discussed in there, and the function of the sedimentation process is as similar as like your water treatment plant. Okay, everything is same. So there, what we have studied is that like. Sedimentation what happens like in screening and in your this in screening, okay, all the floating matters that we separate, isn't it? The floating materials it gets separated, then after here sedimentation we have grid chambers, okay, so the so the this suspended materials or the crates, okay, which are a little bit heavy, so they gets settled there in your grid chamber. So like in sedimentation, why it is done? Because like the materials, okay, those are neither very heavy or they are neither very like they doesn't float in the screening process, the those floating materials that cannot be get trapped, okay. So all those materials you can say or suspended materials, they are being separated in the sedimentation process, okay. So here also similarly like in your raw water engineering we have studied like we keep it for a certain period of time for a detention period, and after that the materials they get settled automatically, isn't it? Here also like similar it is there, and also like the shape and size of the materials, they it can be changed, okay, the shape and the size of the materials or the materials it can be changed by using some you can say chemicals, and those chemicals are known as your coagulants, as we already learned in your raw water engineering, okay. So let us see here, let us read it a bit, okay. So you see here, as discussed in the previous pages, the screens and the grid chambers do remove most of the floating materials like paper, rags, cloth, okay, etc., and the heavy inorganic settleable solids and the sewage. However, a part of the suspended solids which are too heavy to be removed as floating materials and too light to be removed as by grid chambers, they can are generally removed by the sedimentation tank. So I think up to here it is clear to you. Okay, so whatever organic solids, those are very heavy, okay, that to be removed by the grit chamber, and those and like those settleable solids, those cannot be removed by the this screening process, so those are generally removed by your sedimentation tanks. Okay, so you see, the sedimentation tanks are thus designed to remove a part of the organic matter from the sewage effluent coming out from the grid chamber. So whatever effluent is coming out from the grid chamber, that day I showed you one video. So you have seen there that the wastewater, it first goes through the screening, then after screening it goes to the grid chambers. So after grid chambers, it moves to the sedimentation tank. Okay. Okay. So after that, those effluents, they go through the this sedimentation. They enters the sedimentation tanks, and like those these sedimentation tanks, they are designed to remove those organic matter that is coming from the grid chambers. Okay, so like here in the, you see here in the complete sewage treatment, the sedimentation is carried out twice. Okay, so this sedimentation process, it is carried out twice. One is when the before the biological treatment is done, that is your primary sedimentation is done. Okay, before that it is once carried out, and one is carried out after the your biological treatment, or you can say after the secondary treatment or secondary sedimentation. Okay, so this when these chemical coagulants, they are used for fluctuating the organic matter. Okay, during the process of sedimentation, as I already said, that the materials, the shape and size of the materials, it can be changed. Okay, by what? By using a chemical, and those are known as your sedimentation aided with coagulation. This one already we have discussed in your raw water engineering. Okay, so here also similar, it is the process is there. And also there are, in wastewater engineering, there are certain treatment units, or you can say certain sewage treatment units, those work on the principle of sedimentation. Okay, so what are those treatment units? One is your like septic tanks. Okay, septic tanks everyone knows. One is your imhoff tank. Okay, you see here septic tank, imhoff tanks, it will come later. Okay, so this these two septic tanks and imhoff tanks and many others are there. They work on the principle of your sedimentation process. Okay, so now let's see the next one. So basically you see, mm, let us read this one. Okay, it's here written here, you see. The size and shape of the particles, it can be altered by the addition of certain chemicals in water. Okay, so these chemicals are called coagulants. Okay, and they make the sedimentation it quite effective, leading to the settlement even very fine and colloidal particles. So if you mix the chemicals with this matters or materials, so what will happen? Those lighter materials, it will become a little bit heavy, and when it becomes heavy, so that material, it will settle down, isn't it? So that makes the sedimentation process quite effective. Okay, so because settlement is happening, settlement of very fine particles are happening, so that's why. So next is your, okay. So next you see the capacity and other dimensions. Okay. The capacity, oh no, wait, you read it from here. Sedimentation basins are thus designed for affecting settlement of particles by reducing the flow velocity or by detaining the sewage in them. So these sedimentation basins, they are designed, okay, They are designed so that it affects the settlement of the particles. What it does, it reduces the flow velocity. Okay, it reduces the flow velocity, or it also detains the sewage in them. Okay, and so the sedimentation basins, they are made up of what? They are made up of reinforced concrete. Okay, or they can be rectangular or circular in shape. Okay, and these long narrow rectangular tanks with horizontal flow are generally preferred. So there, since there are two, one is your rectangular and the other one is a circular, but the rectangular tanks with horizontal flow, they are generally more preferred than the circular tanks. Okay, so next is your, like, the capacity and other dimensions of the tank. It should be properly designed. Obviously, we will go through the design problem. Okay, so the capacity and the other dimensions of the tank, it should be properly designed. And also, okay, a plain sedimentation tank, okay, under normal conditions, it removes about what, 60 to 65% of the suspended solids. You can remember this line. Okay, it sedimentation tank under normal conditions, how much of suspended solids remove? It removes 60 to 65% of the suspended solids and 30 to 35% of the BOD from the sewage. Okay, this line is important. So it removes 30 to 35% of the BOD from the sewage. So basically, this is the diagram of your rectangular sedimentation tank, and this is a circular sedimentation tank. So we have discussed the sedimentation tank. So let me show you one. I have searched one video regarding your sedimentation. So you first see that video. I think if you see, then you will be getting some idea. Okay, so you first see that video. After that, we will again continue. Okay, you see this video.
And here we have a rectangular sedimentation basin with its influent zone. So the first zone of a rectangular sedimentation basin is the influent zone, and this is where water enters the tank. As the water moves through the tank, it enters the settling zone, and this is where the settling takes place of the particles that will settle out. And at the end of the basin is the effluent zone, and this is where the water leaves the basin. And on the bottom, we have the sludge zone. The sludge zone is where the settled solids collect. So these are the four main zones of a conventional sedimentation basin, whether it's rectangular or circular: the influent zone, the settling zone, the effluent zone, and the sludge zone. And here we can see that there's the sludge collectors moving the sludge to the influent end of this rectangular clarifier for processing. Here we have pictured a round clarifier or a circular clarifier. The water comes in the influent into the center stilling well. This is the influent zone. The water then leaves the stilling well and moves outward through the settling zone. As the settlable particles settle out, they enter the sludge zone down at the bottom of the clarifier, and the outer edges make up the effluent zone. On a circular clarifier, the effluent weir goes around the entire circumference of the clarifier, and that is the effluent zone.
Did you hear, or there's a problem? You couldn't see the video, or you couldn't hear it, and the video is not playing. Okay, from my side it's playing. Okay, too. Others, I don't know. Others, did you watch the video? Could you watch the video or could you hear? Other than Hokkaido, everybody can hear or watch. Okay, well, Hokkaido, I think there might be some network issue. Okay, no problem. You can search this video in YouTube also. Okay, you can see it from there. Okay, fine, good. Okay, then I think you have seen it, right? Then now you could make it an idea how does this rectangular or circular sedimentation tank is working. Okay, so that's why I have showed. If I could show you some videos, then it goes to your mind, isn't it? So that's why. Okay. So next is your okay. Next is your like types of sedimentation tanks. Okay, so there are sedimentation tanks according to shape. We have learned that there is your rectangular and circular tanks we have learned. Okay, but now according to the function. Okay, according to the function, sedimentation tanks, it can be either intermittent or it can be continuous. Okay, so let's see what is intermittent and what is continuous. So you see here, the intermittent settling tanks are called quiescent type tanks. Okay, it is also known as your quiescent type tanks. Are simple settling tanks which store sewage for a certain period and keep it in complete rest. So this tanks, this intermittent tanks, what it does, it gives the sewage or it stores the sewage for a certain period and it keeps it in complete rest. Okay, so after giving it a rest of about 24 hours, so that like I already told that in sedimentation we keep it for a detention period of 24 hours. So after giving it a rest of about 24 hours, okay, during which the suspended particles it already settles down to the bottom of the tank. Okay, so the cleaner sewage, okay, the cleaner sewage from the top, it may be drawn off and the tank, it can be cleaned off. Okay, so now the tank is again filled with raw sewage to continue the next operation. So did you understand this? Like this sewage, it is kept it for 24 hours. Okay, so in that 24 hours, what happens? Does the sewage, the particles, it settles down, okay, to the bottom of the tank, and what happens to the cleaner sewage? It may be it is at the top of the this tank and it may be drawn off. Okay, and after that the tank, it can be cleaned and it can be used, like again filled with raw sewage, and it can be the next operation can be continued. Okay, so that is your like intermittent tanks. Okay, intermittent tanks. And what is a continuous type of sedimentation tank? You see here, like in a continuous flow type of sedimentation tank, okay, which is generally used in modern days. Modern days, that means nowadays. Okay, it's a modern time. So the flow velocity, it is only reduced. Okay, the flow velocity is only reduced and the sewage, it is not brought to complete rest as it is done in a intermittent type. So here the sewage, it is not brought to complete rest. Okay, it is not given complete rest as it is done in the intermittent type. So the working of such a tank, it is very simple, as the water enters from one end and comes out from the other end. Okay, so the water, it is going through the tank from one end and it comes out through the other end. So the velocity, it is sufficiently reduced by providing sufficient length of travel. So here the velocity of the flow, it is reduced. Okay, how it is reduced? It is reduced by providing sufficient length of travel. That means the length is increased. Okay, so now this type of it is known as your continuous type. Okay, so you have understood the difference between the intermittent and the continuous flow type of sedimentation tank. Okay, so now next, next let us see what is there. Okay, so this is a design. So now we will be solving one design problem. Okay, one design problem we will be solving. But for that, you need to know you need to know certain formulas. Okay, so you have to remember certain formulas like what will be V. Okay, V formula. Then again, you have to remember what is the settling velocity formula. Okay, this one is your settling velocity formula. So all these things you have to remember, and certain conditions are also given. Okay, certain conditions are also given. Then again, detention time formula is also there for rectangular tank and for circular tank. Both the detention time formula is different. Okay, so these two are the detention time formulas. Then again, like the effective depth is also given. What is the effective depth is 2.4 to 3.6. So like everything, the overflow rates, okay, it is between 40 to 50,000. So everything is written. Okay, how to design your for designing a problem. So what things you will be needed. So everything is written here. Okay, so you need to go through this. Okay, you need to go through this before solving your numerical problem. But now let me continue with the numerical problem. Later you can go through all this. Okay, okay, so let's see this one numerical. Okay, let us see this numerical. Uh, Design a suitable rectangular sedimentation tank for treating the sewage from a city. Okay, provided with an assured public water supply system with a maximum daily demand of 12 million liters per day. So, what is the MDD? Maximum daily demand is provided as your 12 million liters per day. So, assume suitable values of retention period and velocity of flow in the tank. Make any other assumptions wherever needed. Okay. So here they have assumed, okay, in this question, they have assumed that 80% of the water it is supplied to the city. Okay, 80% of the water that is supplied to the city, it becomes sewage. Okay, so it is assuming here, so you can assume it. So assuming that 80% of water that is supplied to the city, it becomes sewage. So they are finding the quantity of sewage to be treated per day. Okay, so how to find out the quantity of sewage that is treated per day? It is your 0.8. Okay, how much of water it is becoming a sewage? So that multiplied by your MBD. Okay, so it becomes your 9.6 million liters. Clear? So now, now you have to assume a detention period. So since here no detention period is given, so in the notes section you will get it. Okay, that you, for the sedimentation tank, you have to assume a detention period of 2 hours. Okay, so now you find out the capacity of the tank. Okay, you find out the value of Q. It is your 9.6, that is your quantity of sewage divided by 24, okay, into 2 hours. Okay, multiplied by 2. 2 is your hours, right? So it is we are dividing it by 24. Then you will get the answer in cubic meter, that is your 800 cubic meter. Okay, this part you solve it. Okay, so now after you get the capacity of the tank, okay, after you get the capacity of the tank, now you have to find out, since you need to design the sedimentation tank, that means you need the length, breadth and width, isn't it? Depth and width. So first you find out the length. So how to find out the length? It is velocity into detention period. So previously we have already done the numericals, yes. So the formula is your velocity into retention period. So velocity also just now it's 0.3. Okay, it is assuming. Okay, one more assumption is there, assumption is there, it is 0.3. This one also you will get it in the notes. Okay, so the velocity, the flow velocity here, it is assumed to be 0.3 meter per minute. Okay, and it is multiplied by detention period. So what is the detention period? It is 2 multiplied by 60. Okay, so now the cross sectional area of the tank required, you find out the cross sectional area. Cross sectional area formula is what? Q by L. Okay, so it is your capacity of the tank, it is divided by the length of the tank. So capacity just now we got, it is your 800. Okay, this part 800 we already got, and divided by the length is your what? 36 meter. It is your coming to be 22.2 meter square. Okay, the cross sectional area. Now already this water depth. Okay, since here the water depth is not given, and there is no formula to find out the water depth, so like the effective depth or the water depth, it is already mentioned here in the notes that if it is not given, then you have to assume the water depth. Okay, so there is a certain range, and here they are assuming it to be 3 meter. Okay, so as soon as you get the water depth, so you have to find out the width. Okay, the length you already got. Okay, the water depth you have as assumed, and now you can find out the width. Okay, so what is the width formula? It is your area divided by depth. So area we already got it to be 22.2, and depth is your 3. Okay, so after solving you get it to be 7.4. Okay, so it is written here that since the tank is provided with mechanical cleaning arrangement, in the question itself it is mentioned that it is like mechanical cleaning arrangement is provided. So that means there is no need to provide any extra space for your sludge zone. Okay, so that's why no extra space is required at the bottom for the sludge zone. So now we can directly add it up with the freeboard. Okay, we can add a freeboard. So like you got the theoretical depth value. Okay, you have assumed that 3 meter, and so now you have to add a freeboard along with your effective depth of the tank. Okay, so you get it to be, they are taking the freeboard to be 0.5, and after adding it with the effective depth of the tank, they get it to be 3.5 meter. Okay, so now you have got all the dimensions, like you have got the length, you have got the width, and you have got the depth. Okay, so this is your the design of your rectangular sedimentation tank. Clear? So now some more part is there. So here, okay, so now like you have found out the length, width, and depth of the tank. Okay, so now it is okay, this is alternative. Okay, this, I think this process is much easier than this. So there is another process also here. This one is short, but you can you, if you can do this process also, or either you can do this process also. Okay, it depends upon you. I have explained you one process. Okay. Okay. Okay, I need a little bit of break. Can we meet after um, 10:15 or 10:20? Okay, we will meet at 10:15 or 10:20. I will share you one new link. Okay, okay. You can leave this meeting. Okay.